I want to start by thanking RICARDO for putting this day together. I think it's really exciting to bring this diverse group of thinkers and leaders together to talk about innovation, sustainability, and mobility. We sit here in Southeast Michigan as one of the highest concentrations of engineers and scientists really inventing the future, and we don't often take the time out to stop and share how we're thinking about what we're inventing. And so I'm really pleased to be included in this day and very thankful to RICARDO to be putting this day together. I'm going to talk a little bit about building the bridge to the world of connected power and mobility by focusing specifically on the economics of funding the R&D upstream labs and incubator part of the pipeline, all the way to the downstream commercialization and monetizing those new products and services. So I think that's one of the key issues that, frankly, we're having a hard time cracking and maybe slowing us down a little bit. I'm going to start by just giving you a little bit of an overview of NextEnergy, because I think it's important that you understand the vantage point that we have, where we sit, and why we think about how we think about what we do. NextEnergy is a nonprofit. We were formed back in 2002 by the state of Michigan, specifically to help drive investment in advanced energy technologies to really support job creation and job retention in these future industries. But more importantly, I think NextEnergy is a great example of the kinds of public-private partnerships that are beginning to be formed to crack the nut around how do you approach this funding initiative? How do you approach being able to afford the resources to move into that future world of connected power and mobility? As a public-private partnership, we work with very large global players in energy, infrastructure, and the automotive industries. And we work to accelerate the commercialization of technologies by addressing the technologies, of course, but also some of the policy and business model innovation work that really needs to go along at least at the same pace, or actually may be necessary to precede the technology deployment. We're funded by federal, state, and private funds, and that's always a challenge. All three of our funding types likes to know that the other one is in the game too. Nobody likes to be stranded out front of everybody else. So I think it's important that we're able to provide enough value to all three kinds of stakeholders. And what we do is basically three things. We do studies in order to provide input to policy and funding, because somebody has to be able to put together the various voices and talk in a way that is not as much of a vested interest as each of the players tends to be on their own. We also do a lot of services. We do a lot of tech vetting and business consulting to startups and research teams, as well as to the innovation groups at our largest global players. We work with the Ford Motor Company, the GMs, the Fiat Chryslers, the Daimler-Benzes, the Ciscos, the IBMs, the Shells, who are also thinking about what does this new world look like and how do we participate in it. And so we work with the very largest global players and try to connect them effectively with the best fitting innovation pipeline, whether it's at the universities or startup community. And then the third thing we do is we actually sit in a physical space, because physical space matters, as a proof of concept center and deployment center for advanced energy technologies. So we have a 2.8-acre campus right in the heart of Midtown Detroit, where we host a number of incubating companies in our lab spaces, as well as a number of platforms for co-development of advanced technologies. So that's sort of what we do. The reason why we talk a lot about that future world of connected power and mobility is because of where we sit. In the space of advanced energy technologies in Southeast Michigan, we've been very privileged to sit at that intersection of the energy infrastructure, the grid, and the transportation infrastructure, which in the US is predominantly the auto space. And over the more than decade of work that we've done, we've seen that the underlying technologies are common. Energy storage, power electronics, sensors and controls, communications and low latency feedback mechanisms. The underlying issues are common. How do we move into a world where the future infrastructure choices are very different than the past infrastructure choices? So for us, the talk about connected power and mobility is a natural. It's not just the connected power issues of the electric vehicle. It's really the connected power issues of the whole infrastructure that enables both our energy future and our mobility options. We see the common ICT, information and communications technologies, common cyber protocols, common redundancy, latency, and performance attributes in terms of reliability, all being underlying to both the future of the energy grid as well as the future of the connected, autonomous, and multimodal mobility options that we know are coming and in fact are already here. So that's who NextEnergy is and why we think we have something to say about this idea of how do we move from where we are to that world of connected power and mobility. We think that building a bridge to that world of connected power and mobility, of course, involves new technologies and whole new systems. We also think it involves new business models, particularly as we think about funding those common infrastructure investments and how we expect to earn a return for those investments. This is true for both the innovation pipeline, the upstream R&D, incubation, and early product development phases, as well as the education and talent investments that we think of also as the upstream pipeline for that future connected world. It's not just about the products and services, it's about the quality of thinking and problem solving, which is an educational investment. And it's hard to expect our companies to make that in a private market world. So what's the business model for the right investments in talent to be made? The downstream deployment and commercialization of technologies is also a challenge in terms of how does that get funded, primarily because it typically relies on some common infrastructure elements that basically fall through the cracks. The auto OEMs have spent 2 decades, well more than 2 decades if you really understand the history of the electric vehicle, 100 years, working on electric vehicles. Yet they're not necessarily all that interested in thinking about the vehicle charging infrastructure. The utility industry, who's operated the grid for 115 years, is also not all that interested in the vehicle charging infrastructure. Yet the value of the vehicle charging infrastructure for both the automotive industry and the grid is huge. And the risks of it being deployed either using both either a technology or a business model that's not additive is high. So whose job is it to work that particular issue? That's when I'm talking about those common infrastructure leadership roles are some of the hardest ones to fund, shape, and move alongside the same private market roles like electric vehicle development. The main issue behind that common infrastructure for either upstream developments or downstream deployment is really the question of who builds the infrastructure and what are the appropriate business models for building out the infrastructure. Who pays to build it and who earns the return on when it got built. So that, to me, is one of the basic questions about the funding that bridge to that future world of connected power and mobility. And of course, how we think about that question when we factor in sustainability starts to make it really interesting because it impacts how we approach it. How do we factor in the externalities like the environmental impact and global climate change or local health impacts or long-term use of depletable resources that our mobility solutions end up creating or our energy solutions end up creating? For over 100 years, we probably haven't done a great job factoring those externalities into the economics of how we've deployed the current technologies we use. Going forward, we're working harder at being able to do that, and I think the work around sustainability science is helping that quite a bit. One of the other sustainability mindsets that's been helpful in our field is getting better at valuing the diffuse but real benefits that some of these new technologies end up creating. The idea that benefits accrue to us all, but they still require somebody to invest in them and some customer or group of customers to pay for them. In the old world, we had lots of models for that. In the new world, we're still wrestling with how to do that. And then the last piece, and Anne-Marie hit the nail on the head, it's really about what time frame. What time frame are we using to evaluate the value of our technologies? What time frame are we using to set the expectation for returns on the investments we're making in talent, in core science, in R&D, in RD&D, even in centers like ours, which is kind of proving to be kind of an interesting catalyst to move things out of research and into commercialization faster and maybe a little bit more pointed than industry can do on its own. So those are some of the sustainability questions that get factored into how we think about it. So we're really excited about the pace that the sustainability community has been moving on their ability to provide thought leadership on those issues about how do you think about externalities, how do you factor in economic analysis for diffuse benefits, and what are appropriate timeframes. Specifically, the methodologies for thinking multiple timeframes at once. End with my introduction. Now I'm going to focus on what I really came here to talk about. Basically, I think there's three main things when I think about energy and mobility innovations and how do we get to that future of connected power and mobility. One is the trend towards smaller and faster when it comes to provision of goods and services, primarily driven by the availability of data and communications. So I'll talk more about what I mean by that. The second is the tendency for energy and mobility innovations to be systems-based, where the new product or service offering either has to work in the context of the existing system, the car, the grid, the highways, whatever it is, or it will be completely disruptive to the existing system. The e-bike, a smartphone app that actually substitutes for any movement of goods or services. The third idea that I want to talk about is that tension between public goods and private investment as we transition from a century where we got pretty comfortable with what was a public good and how best to fund those. And now we're really struggling with what are the 21st century equivalents of public goods and what are the appropriate cooperative funding models for those public goods. Because if we don't get those public goods built and continuing to be invested, we're all going to go slower and maybe commit some errors that'll end up being costly to us all in the long run. So we'll talk about that smaller and faster trend. We're in the midst of a huge transition from very large, long-lived, asset-based investments, like the utility grid on the energy side, or like personally owned automobiles on the transportation side. If you think about it, for most of the people on the planet, a car represents a capital expenditure. A car may be the largest asset that most families on the planet are ever able to own. So the idea that the 7 billion people on the planet, someday growing to 9 billion people on the planet, are going to continue to invest in long-lived assets like personally owned automobiles for mobility solutions is probably a falsehood. We already know that developing countries are basically sidestepping the grid. The cell phone architectures all over the planet basically sidestepped the land-based landline telecommunications infrastructure. And we're seeing the same thing on the utility grid. And the reason is that those large, long-lived assets have really poor capacity utilizations. And on a planet where scarcity of resources is real, there is a fixed set of materials to be worked with, that idea of assets that are used less than half the time and are some of our largest investments is untenable. Michigan is a summer peaking utility where the top 20% of the assets that sit on the ground year-round are used less than 80 hours. On average, our electric generation assets in Michigan are used 48%. So we built and are paying for twice as much as we need on the energy side. The rest of the planet isn't going to do that. The auto story is even worse. The average personally owned auto is used about 4% of the time. So 96% of the time that is an unproductive asset. That is untenable when you think about a future for the globe. So that trend towards smaller and faster is real. People aren't just innovating products to get that asset utilization up. They're rethinking business models to get that asset utilization up. Products that get asset utilization up on the energy side, grid storage. I can use intermittent renewables that I can build in 1 megawatt units instead of coal plants that I build in 350 megawatt units, because I can pair them with energy storage devices so the intermittency is not a problem with the grid. Just one example of a technology that enables smaller units of investment and faster responsiveness. a battery storage device on the grid is faster than a generation plant in responding to grid reliability needs. On the auto side, we all know the shared business models of Uber, Lyft, Zipcar. That's the way the asset utilization on automobiles is getting improved. So that idea of smaller and faster, it's not just products, it's also the business models that enable higher levels of asset utilization. And frankly, faster, more consumer-friendly responses. Being able to be in Manhattan and not have to flag a car to get from one meeting to the next because I can use my Uber app to do it is awesome. To know that I'm going to get to the airport in 14 minutes when I'm in Queens and it's only going to cost me $11 because of Uber is awesome. That's one of those business model innovations that gets that asset utilization up by getting the unit of investment much smaller. Somebody bought the car, but the person who bought the car is now using it more than 4% of the time. So our units of investment are smaller. We expect to replace our assets more frequently. You think about your smartphone. You replace your smartphone every 12 to 14 months. The device is actually designed to last longer than that, but the average consumer doesn't because they want the next greatest apps. So we expect to replace it more often. We expect to use smaller units of investment, on-call or shared services. And the challenge about all that is, how are we going to pay for all this? Because the only reason why Uber works is because somebody built the ICT infrastructure for our cell phones to work. If there's no model for that next generation of ICT infrastructure that includes the latency requirements and the cybersecurity requirements that these apps are going to need to really be safe and effective on a global basis, how do those business models work? So the challenge is, how do we build them, and who's going to earn the return on those enabling infrastructures for all of these service-based, highly economical, highly sustainable approaches to mobility? In the old world, upstream investment and innovation was paid for through public investment from our government, from our universities, and then some private investments from some of our largest corporations. You think about the space program. You think about our defense industry. Even think about what the federal government has been willing to pay in the medical research field. As we look down the pipeline into our future, it's becoming less and less obvious how those core R&D investments are going to get paid for. Because not only is our government spending down, we don't have a space program, we don't have the defense industry research budget that we're used to, but private investments are down too. Our largest companies that used to fund the R&D, like the GEs, some of us in the room are old enough to remember Bell Labs. Even GM had its own research centers, and still do. But when you talk to the GE CTO or the GM CTO, they will tell us all that they're actually not doing core research. They're doing commercialization. They're doing product development. They're doing process and product enhancements. They still are partnering with the national labs and the universities for their core research. So we really need to think hard about how do we continue to invest in those core assets, because it's not just the what we do, it's the talent we build in those institutions that do it. The way they frame questions and problems, the way they're trained to solve those questions and problems. Am I really down to 1 minute? Okay, we'll go really fast then. So that's one of our main issues. The next main issue that I see is the downstream investments in infrastructure. And again, those were typically made by government. For mobility, it was our transit systems and our highways and ports and airports. And for energy, they were made through regulated monopolies. As we look ahead to what is the 21st century infrastructure that needs to be built, the roadside equipment and DSRC to enable connected and autonomous vehicles, the distributed renewables and microgrid enhancements that will actually create a 21st century energy grid, and mostly the ICT infrastructure, the data architecture, little cloud, big cloud, and highly connective and low latency, high reliability communications networks. Who's going to build them? How are they going to be able to earn their return? It's not likely to be government. The age of the regulated monopoly is definitely being challenged. But somehow we need to come together to fund those core infrastructure elements, because they do have diffuse benefits that facilitate all of our quality of life and safety, security, and economic opportunity. So what do? I don't have a silver bullet. Frankly, I think it's going to require a whole range of solutions to solve this funding issue for the transition from where we are to that world of connected energy and mobility. But I know we will definitely see more reliance on public-private partnerships, where government, university, NGOs like us, and industry are going to come together, because we have to. We'll come together around society's grand challenges, and we'll work in phases, because we're not going to have the long-term stomach to work on it all at once. We're going to work in phases, and we'll co-fund the early stuff, and then privately invest as the markets and opportunities become a little clearer and are de-risked to invite private capital. We're likely to see more co-opetition or frenemy type activities, where companies that might compete in some aspects of their business come to find that they have to cooperate in order to solve these grand challenges. And they're going to come together to jointly develop some of the systems that provide value for society. An example of these are some of the collaboratives that are already forming around connected and autonomous vehicles, and around smart city initiatives, and around industry-sponsored tech challenges. So I think in summary, I'll say that I know that the transition to a connected power and mobility future is already underway. It's not just a technology issue. There's a lot of work to be done in the business model and investment horizon to make sure that we are incenting and encouraging, and in some cases requiring, the investments to be made in the talent, the specific science and deployment, and then the infrastructure to facilitate the transition. Thanks.